Good morning, Emma.
Morning.
All right, what I'm going to do is I'm going to go through a little bit of 6.4 just because my assignment that I gave you guys has a little bit to do with it. And then I'll just answer questions, okay?
Yep.
All right, so all functions and relations, but not all relations are functions. A relation is classified as a function if each value in the domain corresponds to exactly one value in the range. All right. Okay. This was one of the tougher things that I've had to deal with in high school. I could not get my head wrapped around this whole function thing. So I'll do the best that I can to explain it, and I'll keep explaining it until you get it because, frankly, I struggle with this. So by definition, for every x value, there is one and only one y value. Now, we talked about a relation. So all a relation is there's a correspondence between the x and the y value. Okay, so any graph on a grid will have a relationship between your x and your y value. So you have an independent value, independent down here. And the moment that you make it a coordinate, on here, you create a relationship between an x and a y. Now, all functions are relations, but not all relations are functions. So the best way to describe this or to show this to begin with would be with a set of values. So for every x value, there is one and only one y value. So to show this, I'm just going to pick a very specific example here. All right, I'm going to take a set of coordinates. So 1, 3, 2, 4, 3, 5, 4, 3, 2, and 1. Okay.
Yes.
So the very first thing, hi Eli. The very first thing that I look at here is I look at my coordinates and I look to see if there's two x values listed and the same x values listed twice. So when looking at it, I see that I have a 2 here and a 2 here. And the y values are different. Therefore, this is not considered a function. Because by definition, for every x value, there can only be one and one y value only. So what I'm looking for is to see if any x value here listed has more than one y value listed with it. Now, the easiest way for me to show this, though, demonstrate this, is to actually plot these points out. And we use what's called the vertical line test. Okay, so 1, 2, 3, 4, 5. Okay, so I plot the points. 1 and 3, right here. 2 and 4, right there. 3 and 5, right here. 4 and 3, here. And 2 and 1, right there. So we use what's called the vertical line test. And the vertical line test is if I draw a line straight up and straight down, so a vertical line, anywhere on this graph, if it hits 2 points at the same time, it can't pass the vertical line test, which means that's not a function. So if I draw my line straight up and straight down right here, so through the two, like that, okay, that doesn't pass my vertical line test. Therefore, this is not a function. Now, I'll show you a variety of graphs to determine whether or not they're a function. I'll explain that in a second as well. Okay, so graphing wise, if I draw a line, that's a function. The reason that's a function is because it doesn't matter where I draw a line anywhere on here, it's only going to hit 1 point. If I draw a graph such as a parabola, that's still a function. Morning, Cara. That's still a function. I can draw a straight line up and down. That is still a function. I'm only hitting 1 point on it. An example of a graph that is not a function is that guy. Because if I draw that line straight up and straight down, it doesn't matter where I move it to. Let me drag it like this. Can't drag it. Sorry. Thought I could drag it. Let's do this. There we go. So I draw this thing straight up and straight down. I'm hitting more than one y value for the x value. That's not considered a function. Now, what is the real point of this? Well, nothing right now. All we have to determine is what's a relation and what's a function. That's all we need to do as of today. But as we go into grade 11 and 12, we do start to look at graphs and we do start to describe what a function is. So from a list of coordinates, I am looking for an x value that is repeated. So a 2 and a 2, the x value is repeated with different y values. If they're repeated with different y values, they're not considered a function. On a graph, if I draw a straight line, in terms of how I write it as an equation. All right, so I'm going to take the equation. I'm going to use the one in the book here on page 126. So I've got y equals 2x plus 8. So what you learned in grade 9 is that when I write the equation in y equals mx plus b form, all right, I'll refresh your mind, okay? That 8 represents the b. That's my y-intercept. The coefficient or the value in front of the x is considered my slope, okay? So in this case, 2 is my slope. My y-intercept is 8. So this is now a relation. How I find y is I take an x value, I times it by 2, and I add 8 to it. That's considered a relation. The y value is dependent on whatever the x value is, and the x value is independent. Okay? Now, if it's a function, I rewrite the equation like this. F of x equals 2x plus 8. This notation, it is the exact same meaning as what y equals. Y and f of x mean the exact same thing. So why do we write it? All we're doing is making a statement, which is what an equation does, is we're making a statement to say to the person reading the equation that this would pass the vertical line test. This is a function. So what you were taught before is if I took y equals 2x plus 8, I can create a table of values. So I'll just put 0, 1, 2, and 3 in. I would plug 0 in for x, and I would solve for y. So 0 and 8, 1 and 10, 2 and 12, 3 and 14. So what I'm doing is I'm substituting in for x here. So I put a 0 in. 0 times 2 is 0. 0 plus 8 is 8. 1 times 2 is 2. 2 plus 8 is 10. 2 times 2 is 4. Plus 8 is 12. So when they write this out in the book, they're going to write it like this. F of 0 equals. So what this notation simply means is when x is 0, what is y? That's all that means. So I put 0 in wherever I have x. And then I solve for y. F of 0 equals 8. This has a tendency to confuse people. But really, all it means is it's another way to write y. And what is the point of it? The only point of it is to tell you that it's a function. And that's it. Okay? So that's all that we need to know about that 6.4. All right? I'll look at the example in 6.4 right now. So to distinguish between relations and relationships that are functions and those that simply relate in an input-output manner, you must consider all the possibilities of the domain. If it is possible to have more than one output for one unique input, the relation is not a function. So basically what that's saying is if I put in a value for x, I can only end up with one value that comes out of it. If I end up with more than one, it's no longer a function. So it says, carefully consider the relationship listed in the table, state whether the relation is a function or not, and explain why. Sketch a graph of the function. Okay, so in A, working for $8 an hour. So take a look on page 127. They show you the graph of working for $8 an hour. So if you work for 0 hours, you make 0 money. You work for 1 hour, you get $8. You work for 2 hours, you get 16. 3 hours, you get 24. 4 hours, you get 32. And so you end up with a line. Okay, so my line looks like this. Now, if I take a vertical line and I draw it straight down, I can never hit more than 1 point. So if I can never hit more than 1 point, that means it's a function. Putting footwear on before leaving the house, a function. You can wear runners, sandals, or any other footwear, and you have something on your feet. Having footwear or on produces only one output. Baking bread, the temperature of the oven is the input. The range of the output is the height of the loaves. Okay, so the X value can go in, that's your temperature. The range value that comes out could be anything. It could be any height. So if that's the case, that's not a function because for every X value, you can have more than one Y value. Number of hours studying and your mark on your exam. Again, not a function because if you study for 4 hours, you can get 50%. If you study for 4 hours, you can get 100%. So your output can be different. And then any number you choose, it says squaring a number and then adding 3. Any number you choose, and an example is 28. That's a function because you're only getting one output. Okay? Really, this section is just a fill-in section or a filler section to get you to what we want to do next. And that is to work with graphs of lines. Y equals mx plus b. That's where we're at next. Okay? So we are working towards this. Our next section works and focuses on slope. And then we get into y-intercept. And then we talk a lot more about how to graph lines and make sketches on grids. Okay, so that pretty much covers everything up to 6.4. Now, I put in that OneDrive. I put it in yesterday, actually. So there's an assignment in OneDrive that I want you to try and complete for Monday. Okay, I'll take it in until noon on Monday. So you go to OneDrive, and then the assignment will be a chapter 6.1 to 6.4 assignment. Okay, so you can print it off, or you can do whatever, and then take pictures of it, or however you can scan it, and then put it back into that folder, and I'll mark it on Monday. All right. Okay. Any questions from anything you've done this week so far? 6.1, 6.2, or 6.3?
No.
Eli, you're okay? Okay. Emma, Kyra, any questions from 6.1 to 6.3 this week?
Oh, 6.2, 3, and A.
Okay. What page? 119?
Yeah.
Okay. So it says, given the following table of values, determine which relations are linear and which are nonlinear. Describe each relation in words. Okay. So there's two. In all honesty, probably the easiest way in which you do this question would be to graph it and look at it and see if it is an actual line. Okay, so how high does it go? It goes up to 12. So let's have a look and see if we can. Now, I could probably tell from two coordinates. All right, there would be a way in which, but we're not there yet. But if I looked at the slope between two coordinates, I could tell. But let me oh, you know what? I didn't put the negatives on here. Sorry, let me redraw this. Okay, sorry. All right, so I'm at -3 and 6. So -3 and 6 would be right here. -2 and 2, right here. -1 and 0, there. 0 and 0. 1 and 2. Okay, so let's have a look at that. So if I'm looking at this graph, if it's a linear graph, I should be able to draw one straight line, and it should go through every single point I list on that graph. Okay, and I can see right now, it looks not bad going this way, but then it goes over and then back up. So I don't have a linear equation there. That is, to me, the easiest way in which you can show this. All right, So let's look at the second one. So I've got -3 minus 5. Right there. -2 minus 3. -1 minus 1. 0, 1. 1, 3. 2, 5. And then I have 6 and 12. But right now, I look at that one as it's drawn, and I see that it creates a straight line, and it goes through all of my coordinates. Okay? So for you right now, that's the easiest way in which we can tell whether or not it is a linear graph or not. Okay? All right. Okay. Other questions from 6.2, 6.1, 6.2, 6.3?
6.3123 2E.
The granola bars you can buy with a $10 bill at $1.50 per bar. Okay. So for each relation, state the domain and range. All right. That's an interesting one, actually. So what I would do is create a table of values first, Emma. Eli, can you put your thing on mute until you're ready to talk, please? Thank you. Okay, so if I buy no bars, it costs me nothing, right? If I buy 1 bar, how much does it cost me? $1.50, right?
Yeah.
Okay. 2 bars, $3. 4 bars. Oh, sorry, 3. I missed 3. 3 bars, $4.50. 4 bars, $6. 5, $7.50. 6, $9. Okay. So are you following me so far, Emma?
Yeah.
All right, now, so therefore, there's 2 things that we need to recognize. Number 1, the domain for this graph. You can only, if you only have $10 to spend, the maximum number of bars you can buy is 6. The minimum number of bars you can buy is 0, right? So my domain, I can write it like this. I'm going to show you 3 ways to write this. The first way is x such that I put my smallest amount that I can buy. So 0 is less than or equal to x is less than or equal to 6 bars total. Would you agree?
Yep.
Okay. Now, can I buy parts of a bar? Can I buy a half a bar?
No.
No. I can only buy a whole bar. You'd agree with that?
Yeah.
So therefore, I have to add this in. X is an integer. Because I can only buy an exact amount of bar. All right, so a whole number bar. I could use a whole number here because 0 is included. That is possible, but I just like to work with integers when it comes to that. And actually, I've also explained that it can only be 0 to 6. So the integers implies that it's whole numbers. Okay, so that's one way to describe my domain, 0 to 6. Another way to describe the domain would be to write them out. All right, now I wouldn't use interval notation for this, and the reason I don't use interval notation for this is because it is into the integers. I could go 0 to 6, but then I'd have to explain that it's an element of the whole numbers or an element of the integers. So I can do that, but this is not my favorite way to do it when I have a very defined set of values. All right? So the range. Why such that? Okay? What's the lowest amount of money you're going to pay?
0.
0. Less than y. Less than or equal to. And what's the most amount of money you're going to pay?
$9.
$9. So I got to go 0 is less than or equal to y is less than or equal to 9. Now the catch for this guy, if I'm going to write it like this, is I still can have half values for it. So in theory, I can have, all right? The best way to write out this one, the domain for it, would be to again do the same thing I did here, and that's list it. So 0, 1.5, 3, 4.5, 6, 7.5, 9. Like that. Okay? That would probably be the best way to list. When you have very few coordinates or very few pieces of data, listing them is not a terrible way to do it. All right? When I have like great big amounts of information, that's when I want to use set notation or interval notation. Okay?
Yep.
All right. Was there anything else in that? 6-1, 6-2, 6-3? We're all good?
Yes.
Okay. The last thing I want you to know is you got to sleep in from here on in. Class, my videos are going to start going at 10 o'clock starting on Monday, okay? So you guys will be on between 10 and 10:15. I'll try to get as close to 10 o'clock as possible. All right? So
Yes.
10 a.m., you get a little sleep in. That will be your class starting Monday. All right? If you have nothing else, try and get that assignment. Girls, Eli, you guys, have you been able to access that OneDrive yet? Girls?
Haven't tried.
Okay. Maybe try
I
that.
have no idea what you're talking about.
Okay. So let me show you. All right, Eli, so you're on Microsoft Teams. So that's a good start, Eli.
Yes, I am.
Okay, perfect. So now what you have to do, Eli, is just a second. I gotta go back here. Okay, I know it's hard to see, Eli, but you got your Microsoft Teams, so you came in to your Microsoft Office, and I have all of these things here, and I have Teams right here, right? Okay, now you also have OneDrive on here. So you can, you can click on OneDrive. So you go in the same way you get to Teams, and then you click on OneDrive. Okay? And then in the OneDrive, I'm going to have a shared folder for you in which you can access the assignment I put in there. Okay? You all right, Eli?
Yes.
Okay. So, and then you can, do you have a printer at home, Eli?
No.
Okay.
Well, sort of.
All right. So here's your other option. That's okay. If you pull up your assignment and you write it out on a piece of paper, that's fine. And then just take a picture of it and then save it to OneDrive on here, okay?
Okay, then.
Like, give it your best. If you have problems, Eli, just send me another message through Edmodo and that'll work too. I'll just try and keep you going through that, okay?
Okay.
And other than that, that's all there basically is. And I'm going to continue to be on here every morning for you guys at 10 o'clock. So I'm going to continue to go through the material that we have in our book right from here till the end of the year, unless we come back at some point, but it's highly unlikely. Emma, you're okay?
Yeah, I'm good.
All right. Okay. Well, if you guys have nothing else, we should be okay. Let me know. Send me messages through Edmodo or email me at jarrett.newton@mvsd.ca. Okay? All right. Have a good day. Have a good long weekend. We'll talk to you on Monday.
Okay.
Okay. Bye.